Well, today in class we learned how to simplify square roots with variable expressions. So I'm going to do a couple of examples here with you to make sure that you understood what we were talking about in class and to help you a little bit with your homework assignment. So first of all, we have the square root of 44, y to the fifth. Now what we want to do when we simplify a radical is we want to write it in factored form where the first radical is the rational factor of this problem, and the second radical is the irrational factor. Okay, so basically when I look at the number 44, what perfect square is a factor of 44? Well, the number 4 jumps out at you, right? Whoa, that 4, and then 11 is irrational square root. Now, y to the fifth, we know that variables with an odd exponent are not perfect squares, but even exponents are. So what is the greatest even exponent that goes to y to the fifth? Well, it would be y to the fourth. Because when we multiply variables and the bases are the same, remember y to the fourth times y to the first is y to the fifth. Okay? Now that I've figured out which factors are rational and which factors are irrational, we're going to simplify. So the square root of 4 is 2. And then the square root of y to the fourth is y to the squared. Because again, we know that y to the second times y to the second equals y to the fourth. Now my question is, do I need absolute value around y squared? Because remember, when we take the square root of a number, it's going to be positive. Well, since we're squaring this value, then we know then that it's going to be a positive number, so we do not need absolute value. Whoa, where'd that arrow come from? Sorry, folks. I was trying to get the highlighter, but, you know, some things work, some don't. So now let's write down the irrational portion, which would be 11y. So my final simplified answer is 2y squared times the square root 11y. Okay, let's move on. So here we have the square root of 60, a to the fifth, b seventh. So again, we're going to simplify it. So my first step then is to write in a factored form where I have the rational root first and then the irrational factor second. Okay, so I ask myself, which of the perfect squares is a factor of 60? 4, 9, 16, 25, etc. Well, I think 4. So 4 times 60, 15 times. Now, a to the fifth. Now remember, if it's an odd exponent, that is not a perfect square. But the greatest even exponent within a to the fifth is a to the fourth. So we know a to the fourth times a is a to the fifth. And then we ask ourselves, b to the seventh? Well, that would be b to the sixth is the greatest even exponent. That's a factor of b to the seventh. And this would be times b. So now let's take the square root. So the square root of 4 is 2. The square root of a to the fourth is a to the second. Now, do I need absolute value on that? No, I don't, because anything to an even power will come out positive. The square root of b to the sixth is b to the third. Do I need absolute value around that? Yes, indeed, because any number I substituted for b, if it was negative, the result then would be negative. So now I have multiplied by the square root of 15ab. There you go. Let's try another one, okay? Measure. So we have 60, square root of 63, a to the 10th, b to the 8th. Okay, so our goal is to simplify. So again, I'm going to write it in factored form where I have a rational factor multiplied by the irrational